Today we are going to build CodeReady Containers for OKD from source. Hey, what's up everybody? Welcome back to my channel. My name is Aleš Nosek and I am the software practitioner located in San Diego, California, helping you navigate the world of Kubernetes. OKD is an open source project which provides a community version of OpenShift as well as community version of CodeReady Containers. Normally, I would download the CodeReady Containers for OKD binaries provided by the OKD project. And for that, I would navigate to okd.io. And then here, scrolling down, I would go to CodeReady Containers for OKD images. And here I would download the binaries. However, as you see in the moment, unfortunately, there are no binaries available. Don't worry though, because in this video, we are going to build those binaries ourselves. In this diagram, I depicted the internal structure of CodeReady Containers for OKD binary. This is what we are going to be building. I already discussed this structure in one of my previous videos. This video was called Deep Dive into CodeReady Containers Deployment, and I will include a link to this video down below. CodeReady Containers can be installed on 3 different target platforms. It is macOS, Windows, and Linux. And for each of the platforms, CodeReady Containers provides a separate binary. The content of binaries differs between platforms. However, the overall structure is the same. In this diagram, I am showing you the Linux binary. The binary consists of 4 parts, which are all bundled together to form the binary. The first part is CRC executable. This is the executable code which is running when you are executing CRC commands. The second part is admin helper Linux. This is a utility used by CodeReady Containers to, for example, edit your etc host file on the target Linux system where you are deploying. The third part is CRC driver Libvirt. This is a daemon which is running during the CodeReady Containers deployment. This daemon abstracts away the details of the target virtualization platform so that the CodeReady Containers core doesn't need to know exact details. And the last part here is the largest one. This one is called CRC Libvirt bundle. And this bundle is an archive, and there are several files in it. So the first one is the CRC bundle info, which is metadata file. The second file here is the CRC QCOW2 container image. So this is the container image with pre-installed single node OpenShift cluster. Next, in the archive, we have a private SSH key, which is used during the deployment by CodeReady Containers in order to SSH into the virtual machine. Then we have a kube config here, which was generated by the OpenShift installer and which allows the authentication to the OpenShift APIs using the client certificate, which is inside. And the last one here is the OC executable, so which is the OC client, which matches the version of the OpenShift cluster bundled in the CodeReady Containers binary. Source code of the CodeReady Containers project is hosted on GitHub. You can find it at github.com under the organization code-ready. And I'm going to include all the links to the Git repositories down below the video. As you can see, each individual part of the CRC binary is built from a different or separate Git repository. First, we are going to use the scripts from the snc Git repository, also known as single node cluster. And these scripts will build the CRC bundle for us. Second, we will check out the CRC Git repository and build the CRC executable from source. This CRC repository also includes scripts to finally assemble the entire CodeReady Containers for OKD binary. The other 2 repositories here in the picture, admin helper and machine driver Libvirt, they include source code to build the other 2 parts. However, they also provide already built binary artifacts. And so instead of building from source, we are just going to grab those binary artifacts and include them in our CodeReady Containers for OKD binary. As there is a lot of work to do, I divided this effort into 2 videos. In this video, we are going to build the CRC bundle. And then in the follow-up video, we are going to build the CRC executable, as well as assemble the final CodeReady Containers for OKD binary. To build CRC bundle, we will need to clone the single node cluster Git repository. This repository is also used by Red Hat when building CodeReady Containers. And in the README file, we can find the instructions on how to use this repo to build the OKD version of CodeReady Containers. And for that, we will need to create a fake pull secret, which pretty much uses credentials foobar. It's not really used. And then we will also need to export the OKD version, which we would like to embed into the bundle. I cloned the single node cluster Git repository. The next question is which commit we should be building from. And for that, I prefer to use the exact same commit as was used to build the official CodeReady Containers. And in order to get that commit ID, we will need to inspect the official CodeReady Containers distribution first. The official CodeReady Containers distribution is publicly available. You can find it at mirror.openshift.com. And then I browse under OpenShift v4, clients, CodeReady Containers. And here I am grabbing the latest release of CodeReady Containers. I will also include the link to this location down below. I downloaded the official CodeReady Containers distribution, and I already decompressed the distribution archive. If I go in, then you can find the CRC binary right there. The CRC bundle is embedded within this binary, and in order to be able to look at its metadata, we will need to extract that bundle from the CRC binary first. CodeReady Containers use binappend Golang library to assemble the CRC binary, and binappend comes with this binappend-cli utility, which allows us to extract the parts embedded in the CRC binary. We need to install the binappend-cli using just this one go command, and I'm going to include the link to this binappend-cli Git repository down below the video. I copied the command to install binappend-cli. We'll execute it now. And now with binappend installed, I can use it to look at the CRC binary. So I will run binappend-cli read, and then is the name of the binary I'm looking at, and then I will dump the table first, which will show me the content which is inside of that CRC binary. And I'm interested in extracting this CRC bundle here. So for that, I will just mark that bundle to be extracted, and then binappend-cli is going to extract it on the standard out. So I'll just redirect it somewhere else. I extracted the CRC bundle out of the CRC binary. Let's take a look at what kind of archive it is. It is a Z-standard compressed data archive. And I also happen to know that inside there is a tar archive. So in order to decompress this and untar it, I will just run this one command, tar through the zstd filter, and then extract verbose file and that CRC bundle. And you can see that indeed the CRC bundle info, which is the metadata I'm looking for, is extracted. And the rest of it will take a while, so I will pause the video here. After a while, the CRC bundle finished decompressing. So now I can open a new console window to look at its content. I'm especially interested in this CRC bundle info metadata file, where inside in the snc version, there is the description of the git commit from which this CRC bundle was built from. And so I can take this commit description and then go back to the snc git repository and check out that particular commit. Based on the instructions from the snc git repository, I created my fake pull secret. As a build machine, I'm using a Fedora machine, release 34. And I pre-configured this machine, I installed Libvirt on it and enabled KVM. Before I run the build command, I wanted to show you some customizations which I made to the scripts. So git diff, actually virt diff would be better. So the scripts were accessing Libvirt over TCP. Instead, I am changing this to access Libvirt over SSH and then the local Unix socket, which is a more secure connection. And because Libvirt will be accessed only by the OpenShift installer command, it is completely acceptable in this situation. Also, I discovered a bug while I was running the build before. The OpenShift failed to install, and the workaround for the bug is to allocate more memory for the bootstrap node. So instead of the original 4 gigs, I am passing this parameter here to the installer so that 8 gigs of memory gets allocated. And I will post the link to the respective GitHub issue down below the video. Now I can paste in my build command. I'm going to use the latest OKD release to build my bundle. I am disabling the certificate rotation. I realized that possibly the latest OKD is buggy and the kubelet server certificate fails to rotate. So that's why I'm disabling it here so that the script won't fail. Then I am passing in my OpenShift pull secret. And also I am timing the command so that we can see how long it took to install OpenShift to Libvirt. I am using the v and x parameters, verbose and debug parameters, so I get more shell output for possible troubleshooting. And that's the complete command. So I can run it now and it will take about 45 minutes to complete. So I can pause the video here now. While the snc script is still running, let me walk you through it. Overall, the snc script will perform OpenShift installation. It will install a single node OpenShift cluster to the Libvirt target. At the beginning of the script, we run some pre-flight checks to ensure that our build machine is correctly configured. We mainly check that the Libvirt is functional and also that we have the networking set up properly. After that, we will download the OC client for the respective OpenShift version that we are going to bundle. And we use that OC client to grab the respective OpenShift bare metal install. OpenShift actually comes with 2 versions of OpenShift installer. The regular OpenShift install command doesn't really support the Libvirt and bare metal targets because those targets are not compiled in. On the other hand, OpenShift bare metal install command supports everything what the OpenShift install, but also it compiles in the support for Libvirt and bare metal. This bare metal installer is distributed on the bare metal installer image as part of the OpenShift distribution. I'm not exactly sure why there are 2 installers, but it is a fact. Actually, giving it a bit more thought, I realized that the OpenShift installer binary is a statically linked executable. And so this one will be portable and will be running on any Linux distribution. On the other hand, if I check out the OpenShift bare metal installer, that one is a dynamically linked executable. It requires the Libvirt libraries. And so this one, if you want to run this one, you need to install Libvirt before that. So also because the OpenShift bare metal IPI method uses Libvirt, then it makes sense to put the Libvirt target and the bare metal target into this OpenShift bare metal installer. And so practical reason of being able to statically link and then have a separate executable which needs to be dynamically linked, that will be probably a good reason to have two different binaries. Next, we are going to run the OpenShift install destroy cluster command. In the case that you are running this script for the second time and there was a previous OpenShift installation, the OpenShift install destroy cluster will remove that installation first before reinstalling. Before running OpenShift install, the snc script will configure Network Manager to start an instance of DNS mask server. DNS mask is used as a DNS server which can resolve the well-known OpenShift endpoints, and this is needed for the OpenShift installation to succeed. So after the snc script changes the Network Manager configuration, it will also reload Network Manager. Next, snc script is able to rotate certificates. We are talking here about the kubelet client and kubelet server certificates. Those certificates are initially expiring in 24 hours, and so snc is able to rotate them, to trigger the rotation, so that they will be replaced with certificates which expire after 30 days. And in order, if you choose so, to do the certificate rotation, snc is going to set the time on the machine back by 1 day, so that happens before the OpenShift installation, so that right after the installation is complete, snc is going to set the time back to the current date, and this will force the 24-hour certificates to expire and to get rotated. The kubelet server certificate is automatically approved when it is rotated. The kubelet client certificate will be automatically approved by the snc script. As a next step in preparation for the OpenShift installation, snc is going to generate the install-config.yaml. So this is the installation descriptor which will tell the installer to install OpenShift on the target Libvirt platform. Also, snc is going to use the OpenShift installer to create manifests. As you can see, we are using here the environment variable OpenShift install experimental cluster profile, which is set to the single node developer profile. So this cluster profile functionality is currently not available in OpenShift 4.7, but will be available in future OpenShift versions. And this functionality allows you to choose a cluster profile you want to install. The installer will pass this profile information to the cluster version operator during the installation time, and the cluster version operator, based on the selected profile, will choose which operators will be installed and which will be skipped. There are operators which, for example, for a single node installation for developers, make no sense to be installed, and so those can be skipped, and that's what the profile can achieve for you. Now, because this functionality is not available yet, and instead of using cluster profiles, snc is instead generating or modifying the CVO overrides file, and simply snc will set some of the operators which are not supposed to be installed. It will set them into the unmanaged state, so that when the cluster version operator is deploying operators, it will not deploy those operators at all. The snc script modifies several other OpenShift manifests before installation. It, for example, sets the custom domain for the ingress, and also it modifies the parameters of the virtual machine. It will create an OpenShift virtual machine with 14 gigs of memory, 6 vCPUs, and 31 gigs of disk capacity. After the OpenShift manifests are customized, snc script is going to issue the OpenShift bare metal install create ignition configs, which will generate ignition configs. And after that, snc is going to start the OpenShift cluster installation by issuing the OpenShift bare metal install create cluster command. Also, snc spins up two processes in the background, which will ensure that the etcd cluster as well as the authentication operator will install correctly on a single node OpenShift cluster. The OpenShift bare metal install create cluster command will block and wait until the OpenShift installation is complete. And right after that, in the case that we were interested and enabled the certificate rotation, then after the installation is complete, we are going to set back the time on the machine to the current date and current time. And because the kubelet certificates will now be rotated, the client certificate requires the approval of the CSR. The snc script will be waiting for that CSR. And as soon as it sees the CSR, it will also automatically approve that CSR, so that at this point the kubelet certificates are rotated and the new ones are expiring only after 30 days. After we are done with the kubelet certificate rotation, we can SSH into the OpenShift virtual machine and set the host name for the machine statically so that it survives reboots. After that, we are going to generate the metadata JSON file. So this is the file which we were inspecting when we were trying to find out which exact git commit was the official CodeReady Containers bundle built from. And in the next step, we are going to create a bunch of persistent volumes for the user, so that when the user in CodeReady Containers creates a PVC, those volume gets bound for the user and it can be used for the user's applications. Next, we are going to patch the cluster version object on OpenShift. This cluster version is the configuration for the cluster version operator. And here with this command, we are marking further cluster operators as unmanaged so that we can later on remove them from the cluster. And it is important to mark them as unmanaged because otherwise, if you try to delete them while they are managed, the cluster version operator is going to recreate them. If you recall, we were removing some of the cluster operators already before we started the installation. We modified the OpenShift manifests and marked them there as unmanaged. So why are we removing some of the operators at this stage after the installation is already complete? Well, it turns out that some of the operators, like for example, OpenShift machine config operator, are required for the OpenShift installation to even succeed. So we were not able to remove machine config operator before the installation, and we can only remove that operator after the installation is already complete by patching this cluster version object on OpenShift. We are going to remove the machine API operator. This operator allows us to grow the OpenShift cluster by provisioning additional machines and adding them as nodes to the cluster. Because our CodeReady Containers cluster is going to be a single node cluster for its entire lifetime, we have really no need to keep the machine API operator around. Next, we are also removing the machine config operator. This operator is responsible for configuring some of the basic components on OpenShift nodes, like for example, machine config operator configures the kubelet as well as the cryo runtime. And I was wondering if some of the functionality which machine config operator provides won't be missing in CodeReady Containers. I was thinking because machine config operator also configures the cluster-wide proxy in your kubelet and cryo runtime, or it is also configuring the image registry mirroring or trusted certificates for image registries. I was wondering if this functionality won't be missing. I actually realized that the CodeReady Containers, they re-implement some of these functions, so you can use them from CodeReady Containers, so that's covered. And also CodeReady Containers provides guidance how to configure the other parts so that you really don't need the machine config operator. And by the way, because machine config operator is not running on CodeReady Container nodes or node, then you can always edit any files under /etc yourself, and they won't get overwritten by this operator. After cleaning up some of the unneeded cluster operators, we are going to scale down the number of routers to just single replica because we do have only one node here in this cluster. The same, we are going to scale down the number of replicas for the etcd quorum guard to only one replica. Because we only have one etcd node running, we only need one health check for that node. And next we are going to expose the integrated image registry using a route. This is a convenience for the user so that the user can push the container images from outside of OpenShift cluster into the integrated image registry using this route. Next, we add a tip to the login page for the user, so that's a convenient information for the user. And then we are going to generate the HTTP password file, so the Apache style password file with the two users, with the admin user and the developer user. So this is the authentication file, and right after that we are going to configure that kind of authentication, HT password authentication on OpenShift right here. So when we now have that user authentication configured using the HT password method, we can remove the bootstrap authenticator. And after that, we create a security message on the web console. I will get to this one later in the video one more time. We remove the pull secret, which we used during the build. We will replace it with an empty one because we expect the user will bring its own pull secret. And then we are also going to wipe out the cluster ID. The cluster ID is a unique ID which should identify a cluster. And so we would not like to get this same cluster ID copied with every single installation of CodeReady Containers. Instead, we will wipe it out here, and then at the start of CodeReady Containers, the new cluster ID unique to that particular instance of CodeReady Containers will be generated. Next, we can remove the machine configs and machine config pools objects from the OpenShift cluster. As the machine config operator is already gone, there is nothing which could act upon those objects. So let's remove them. And as a next step, we are going to copy the kubeconfig file, which was generated by the OpenShift installer, and which includes the private key and certificate, allowing the user to log in to OpenShift as admin. We will copy this kubeconfig file to the CodeReady Containers virtual machine into the location under opt. It will be /opt/kubeconfig. In the next step, we will further customize the cluster operators. The cluster operators are managed by the cluster version operator, and there is a set of manifests which is baked into the cluster version operator image, which describes the deployment of individual cluster operators. And so what we would like to do is to override or customize those manifests so that we can change different parameters of deployed cluster operators. How can we override the cluster operator manifests which are baked into the cluster version operator image? The snc script will first find the cluster version operator pod running on the cluster. And after that, it will actually rsync all those baked in manifests out of that pod. They are stored in the pod under the /release manifests. So from this location, we will copy them out and store them on the OpenShift virtual machine under /opt/release manifests. So now we have a copy of those operator manifests on the local file system in the virtual machine. So in the next step, we can now modify those manifests and customize them. For example, we are going to scale down the number of replicas for some of the operators from 2 to 1. And we are going to also remove the memory request for those operators. So that allows those operators to start even when the memory request would not be able to be fulfilled. So now that we have the operator manifests customized, we will mount them as a volume. into the cluster version operator. So we will patch the deploy cluster version operator deployment and mount a host path volume with all those manifests into the exact same location where those baked manifests used to be, so /release manifests. And this way, after the cluster version operator pod will restart, it will actually use our customized operator manifests. Because we modified the configuration of cluster operators, we will now wait for those cluster operators to stabilize. It means they should stop progressing, they should definitely not be degraded, and they should be all available. So after we reach that state, we will, as a last step in this script, also clean up some of the pods which ran into completion, and then we are done. In the meantime, the snc script ran into completion. We can now check the state of our OpenShift cluster after installation. So I will open a new terminal window. CRC stores the installer artifacts under CRC temp install data. So from here I can also grab the kubeconfig file, which allows me to log into the OpenShift cluster as the admin user. And first I will take a look at the cluster version object. From here I can tell that we are running an OKD release of OpenShift. Next I can check out how my cluster operators are doing. They are all available, they are not progressing, and they are not degraded, so that is a clean state. We can also check the nodes in the cluster. We do really have only one node here, and that one plays the role of master and the worker node at the same time. And as a next step, we can go and take a look at the OpenShift console, and for that I will grab the URL of the console first, and then I can copy paste it into my browser. After I logged into OpenShift console, everything looks good to me. I'm just not fond of this banner here, so I'm going to remove it, and I need to remove it now so that we can bake the image and it won't be there anymore. So let's take a look where that banner comes from. I will grab for it in the CRC source code. So I'm looking for that text which I saw on the banner, and here I can find that it comes from this security notice file, which is a console notification kind object. Okay, so in that case, let me take a look if that object is there. So kubeconfig CRC temp auth config oc get that file. Okay, the banner is existing on the cluster, so let me just remove it. Oc delete, and that's it. Let's check out again the browser, and the banner is gone, so that was easy. Before we create the CodeReady Containers virtual machine image, let's do one more modification, and for that I'm going to SSH into the virtual machine. So let me find out first where that machine is running. I'll get the domain interface address of the virtual machine, and then I can SSH to it using the key which was stored for me during the snc script run in the current directory, and SSH to that machine. So now I am here as user core. I can go to the SSH directory, and here I can see that there is an authorized keys file, which would be fine. But the problem is that this file is incorrectly owned by the user root and group root. I reported this issue to the OKD project, and I will also link the issue report down below the video. So what we need to do now is to change the ownership of this file to be owned correctly by user core and group core. Okay, so with this modification complete, we are now ready to bake our CodeReady Containers image. Now I can paste in my command to create the virtual machine image bundle. And so I'm using or running the create disk script, which is available in the snc repo in the root. And I'm passing the OKD version to this script. And also I'm telling it where the OpenShift installer artifacts are located. So this is the default directory. And while I'm running this command will now stop the virtual machine and will create a QCOW2 image disk. And then it will archive and create a bundle with that disk inside. After about 4 hours, the build of CRC bundles is finally complete. So let's take a look at what is in our snc directory. We can see that there are 3 bundles. There is a HyperKit bundle for macOS. Then we have Hyper-V bundle for Windows. And last one is the CRC Libvirt bundle for Linux. And next to those bundles, there is still the directories which contain the content, which was then archived into the bundle. So let's take a look at that content on all those platforms so that you can see that the content is pretty much the same. And as you can see, the list of the content of the CRC Libvirt bundle, that one is already very familiar to us because it is the same list of files we have seen when we were extracting the official CRC bundle. Let's review what we covered in this video. We reviewed the internal structure of CodeReady Containers for OKD binary. We found out that there are 4 components bundled inside. There is the CRC executable, the admin helper Linux utility, the CRC driver Libvirt, and then the largest part, which is the CRC Libvirt bundle. We spent the remainder of the video building our own CRC Libvirt bundle. And for that, we first reviewed the single node cluster shell script. We used this shell script to install OpenShift as a single node cluster on Libvirt. And after that, we ran the create disk shell script, which created a bundle. And this bundle or archive included the virtual machine image of our single node OpenShift cluster. In the next video, we will build the CRC executable. Then we will finally assemble the entire CRC binary. And we will also test this binary using the end-to-end test suite, which comes with the CodeReady Containers project. I hope you enjoyed today's video. Please feel free to leave your questions or comments down below. If you found this video helpful, please consider subscribing so that you are notified whenever I release a new video. Until next time.